All right, guys. So we're going to go back and look at the program of study program that we, the class, program class, whatever you want to call it, that we introduced in the last chapter. So we noticed when we did that it implemented the iterable interface, and it has an iterator method that returns the iterator provided by the list. So basically, when you iterate over the program of study, you're going to be actually iterating over the internal list. And we have this program of study grades class that uses a for each loop to print all the courses with a grade of A or A minus. So let's look at some of the code here. So we notice that, again, this thing is it implements iterable course. And that means that we're going to, the iterator that's going to come back, the element that's going to iterate over are courses. It's serializable. Internally, we have this private list of courses, which we're implementing as a linked list for the course, full of courses. We've seen this, so we're going to go through this pretty quickly. Add course, again, just adds it in. Finds things, etc., etc., etc. Replace to string. All right, so here's the iterator interface implemented. So the iterator for this particular object is going to return it's just going to return the list.iterator. And so this list class, so this list class is iterable, right? So we're just going to return the list iterator, which is going to take place of the course iterator. Because when you're iterating over this program of study, we're really just iterating over the internal list, right? So that's what we're going to give you. Now, there's a question here. Is that really what you want to do in terms of class design? Because you're sort of handing back an iterator to an internal data structure. And we go back and we look at this and we notice that we declared this thing private, which means that we do not intend to give, for people to be able to access this. And then we go and we hand out iterators to it, which is, I don't know if that's a good idea or not. Because, once you have this iterator, you can remove elements, you can do different things to it. I guess you have a limited interface to it, but you still can remove things, and you can, there's a philosophical question of should I be doing that? And I don't know the answer to that. Personally, I wouldn't write it like this, but some people will. All right, so we have this serializable thing, which, again, we writes things out. We've seen this. We've seen the reverse one. So let's look at this one. This is the most interesting one, I think. We've got this POS grades. So we have public static main. This is going to use, so this is our driver, right? So it's going to print out all of the classes with grade of A or A minus. So here we're going to loop over our POS, our program of study. We've loaded it from the disk using the deserialize method. And here we're going to loop. So we see that we have this iterator. We have this iterator syntax that we've seen before. So what this is going to do is, this is the list, this is the collection that we're going to get the iterator from, and then this is the variable that's going to hold each element as we go through the list, right? So we're never going to see the other iterator with this syntax. What we're going to do is we're just going to see, so the first time we come into this, we're going to have the course is going to be equal to the first element in the list, and then we're going to do our thing, we're going to go up, and then when we come back through, course is going to be equal to the second element. So there's no manual incrementing. This is done in the loop for you. And there's no iterator here that you have to call .nextOn or .equals or whatever. Now, of course, internally it's doing that because it must be. But from our perspective, we don't have to worry about that. This is, again, it's syntactic sugar. It makes it look pretty. And it looks nice. But in reality, what it's doing is it's translating it back to what we were looking at before with the while loop. So we can use this inside of our loop just like it's an element. So we're going to call if course.getGrade.equals A, or course.getGrade.equals A minus. So if it's an A or A minus, we're going to print. And remember, this is just going to loop over everything that's in that program of study list object. So now we're going to use an iterator to remove any course in the program of study that doesn't already have a grade. So since we're going to use the remove method, we cannot use a for each loop. So we can't use the for each loop syntax. That's only good for iterating over things when we're going to go through all of them. We can't delete things. So you should think about this. There's a difference. So we could, well, I guess in Python you really can't do that. Not Python, Java. You really can't do that. But in other languages we could delete things here, but we wouldn't want to do that. That would be really, really bad. So in this case, we're going to use the remove method and we cannot use the for each loop. So let's look at how that works. So we're going to look at removing courses with no grades. We're going to get an iterator for the course, which is just from the POS iterator. Remember, this is going to be a list. This is going to iterate over the internal list. And so we're going to say while itr.hasNext, same loop we looked at before, course equals course.next. And then if not course.taken, meaning that this thing doesn't have a grade, we're going to call itr.remove. So this is kind of a weird thing, right? So when you call .next, you can sort of think about this thing as like a pointer, and it starts out, when you get it, it starts out pointing at the first element. And when you call .next, it gives you the element that's stored in the current node, and then it increments the pointer, right? But then when you want to remove it, it removes the thing that was the previous one. It's really kind of an odd thing to think about, but just take into account that if we use this syntax and we say course equals itr.next, it's going to give us a course. And if we call itr.remove, it's going to remove the element that corresponds to the course that we just got. Okay, it's going to remove this one. It's not going to remove the next one. It's going to remove the current one, even though we've called .next on it. So think about it how you want. It's an odd syntax, but that's the way they wanted to do it. So this is how it works. So we can use the object that we get back, the element that we get back, just like a normal element. And then if we call itr.remove, it's going to remove the current thing that we just get. It's going to remove the element corresponding to the class, the object that we just got out of the collection. Okay. So we're going to print this out, and then we're going to call save. So we're going to go through here. We're going to delete all the things that don't have a grade, and then we're going to save it. All right. All right, so that's the end of the lecture for this one. We've gone through some examples of how to use these things. We'll continue this next lecture.